Suppose I get my polynomial x cubed minus x squared plus 2x minus 3, and then I divide it by the simple linear factor x minus 2. I end up with this, x squared plus x plus 4, as my quotient, and 5 is my remainder. Now think about what happens if I evaluate my polynomial at the value 2. Notice this 2 is the same as the 2 in my divisor. That's important. So I evaluate my polynomial at 2. Well, p of 2 using the right-hand side is 2 minus 2, which is going to disappear because it's 0, so I don't care what goes here, plus 5, the remainder. So p of 2 is 5. Just to show you that it's exactly the same even if you substitute into the original polynomial, let's put it in here. 2 cubed is 8 minus 4 plus 4 minus 3. So these two terms cancel out and it's going to be 8 take 3, which is 5. So the remainder, when my polynomial is divided by x minus 2, is equal to p of 2. Now this result holds in general for any polynomial and any linear factor. If I divide it by x minus a, I will end up with the remainder that I have when I substitute a in. Why does it work? Because if I'm dividing by x minus a, this first term is going to be 0, because the first factor is 0. So if this term is 0, I'm left with just the remainder. This result is called the remainder theorem. If I divide my polynomial by x minus a, the remainder will be p of a. But this leads us to an even more useful result, and you'll see how we use it to solve polynomials in what's coming. If I put in x minus something and I get a remainder of 0, then I have found a factor of my original polynomial. What's a factor? A factor is just something that when I divide by it, I have no remainder. That becomes important for solving this polynomial later. So, the factor theorem says if p of a is 0, then x minus a is a factor of p of x. That is to say, if I can find a value a for which the remainder is 0, then I have found a factor of my original polynomial. Sometimes you have to be a little bit careful with negative signs. We always write it as x minus a, but sometimes it might be a plus, x plus 2. Well, when you divide it by x plus 2, the remainder is p of the minus 2 part, because it's x minus negative 2. So the remainder is p of negative 2.